Well, I'd like to start with some thanks, too. I think this is for me, I'm really honored to be here today to give the Feldstein lecture, and I want to start with some thanks. First, I just want to thank the NBER. It's almost difficult for me to thank the NBER because it's been so important in my life. The first time I showed up at the NBER was when I was an undergraduate as a research assistant, and I have never missed spending some time at the NBER in any year since then. My first summer institute was actually the year after I graduated from undergraduate school at Harvard when I was invited to go to summer institute. It was still at Quincy House at the time. And whenever I'm at the NBER, I always feel that it's my home away from home. So it's been incredibly influential in my life, and I just cannot imagine having become an economist without the NBER. But then also, I really want to say that I'm honored to give this lecture because it is in honor of Marty Feldstein. Marty has been probably the single most influential economist in my life. He was the first person to teach me college-level economics. He taught me principles of economics. In fact, I believe I attended his first Principles of Economics lecture. Don't look up the date of that lecture, please. I also attended his last Principle of Economics lecture because by then I was his colleague at Harvard, and we were colleagues for, I think, 13 years at Harvard. I had him as an undergraduate, and I can still remember many things that he said in the two classes I took from him, but especially his American Economic Policy class. And believe it or not, I often quote some of the things I probably remember better than he does. I still quote some of the things that he said, not just to my undergraduates, but to my graduate students, and I do give him proper attribution. But then we served together as colleagues. We co-taught both graduate and undergraduate public economics, and I can tell you that I learned an enormous amount from co-teaching with Marty, but also from just sitting in seminars with him every week and hearing the sorts of questions he asked and the sort of way in which he thought. He has a remarkably, remarkably incisive mind. He is really dedicated to first principles in economics. He always sees the big question in a question. I never tire of hearing Marty's comments and questions. And I should say that for all of you who may not have had as many opportunities to spend time with Marty, you can always spend time with his papers. And his papers are very much like his beautiful mind. They are very clear. They go right to a point. And there is a reason why so many of them are seminal papers in economics, and especially in public economics. Anyone who teaches graduate public economics will teach many of Marty's papers and will know that they are some of the easiest papers to teach to PhD students precisely because people take away so much from them and they're so influential. So thank you, Marty, for all that you have done for me over the years in every way, and I am very honored to be giving the Feldstein lecture today. Okay, so what I'm going to talk about today is the economics of the market for higher education in the United States. And I think that we have an incredibly unique and exciting market for higher education here, and one that is not only informative about our own country, and maybe about highly developed countries, but is deeply informative about what happens in tertiary education. So I'm going to try to get to all of that today. By the way, there's a short disclaimer. Some of the slides are based on a paper that I gave last year at Summer Institute. Many of you will have seen it, and therefore there's a disclaimer that this does not represent the views of the Treasury or the Internal Revenue Service. Okay, so let me just tell you what I'm going to argue today to put it all out there, because there are several pieces to the argument that I'm going to make. The first part of the argument that I'm going to make is that in our market for higher education, we see a very strong correlation between the educational resources that a student experiences and his or her college readiness, which from now on I'll just call CR, okay? And college readiness is a combination of probably innate aptitude and also preparation. So I'm just going to call it college readiness so that you know from now on it's just this combination of probably ability and preparation put together. This correlation between CR and educational resources experienced is considerably stronger in the parts of the market where market forces appear to be more powerful, and I'll show you evidence of that. The next part of the talk is going to be about the productivity of American post-secondary institutions. Over the past year, I have been working on measuring the productivity of every U.S. post-secondary institution, and what I'm going to do is show you the results of that work. I'll tell you a little bit how I got there, but I'm mostly going to show you the results and then show you that they have fairly strong implications for what must be going on in this market. I am going to show you that the productivity of a dollar of educational resources appears to be fairly similar across all of the selective institutions in the United States, from the most selective, like Harvard, Yale, Princeton, Stanford, University of Chicago, et cetera, to those that are just selective, somewhat modest, very modestly selective. And I'm going to suggest that market forces may be the reason why we have very similar productivity of a dollar. Okay, that doesn't mean they all spend the same amount, but a dollar produces about the same amount of value added. I'm also going to show you that productivity of post-secondary institutions appears to be lower and is much more dispersed, much more different among the institutions that are non-selective, and they appear to experience much weaker market forces. So I'll make an argument that there's a connection between those two things. If productivity in higher education is important for growth, a point to which I will come back at the very end of my talk, it may be a bit of a problem that the U.S. market for higher education is largely expanding its enrollment in the non-selective tier, where market forces appear to be weak and productivity seems to be lower. Then finally, I'm going to conclude by talking about the implications of all of this for economic growth and for income equality. Because if we take these productivity results seriously, and we also take the results seriously about the relationship between educational resources and college readiness, then it is almost impossible to escape the suggestion that a particular model of education production applies in tertiary education, and that model exhibits single crossing. Single crossing is the idea that people who have higher college readiness benefit more from any additional unit of educational resources. And once you get that single crossing condition, it has pretty profound implications for economic growth, for potentially policy in the tertiary world, and also it has consequences for income equality. So I will try to get to all of that in the talk today, and I will probably speed up at some point as I flip through the figures. Okay. So part one, I'm just going to talk a little bit now about the U.S. market for higher education, and part of this is to remind you of what it looks like, because most of the people in this room are not associated with representative institutions. I will say that I think the U.S. has the only true market for higher education in the world. You might disagree with me a bit on this, but it is undoubtedly the most informative market. And the reason is that market forces still dominate this market. It's not that the government doesn't intervene. The government intervenes in numerous ways in our market for higher education, but we do not have a centrally controlled market. There is no national government setting tuition. There is no national government allocating students to different universities or deciding which universities should get resources or faculty or anything like that. And that really sets us apart even from our nearest counterparts, probably the United Kingdom, Canada, et cetera. We really have a market that is dominated by market forces. Our market exhibits very strong variation. The top and the bottom look nothing like one another, where by top I mean the most selective institutions, and by the bottom I mean the non-selective institutions. What I'm going to show you is that at the highly selective end of the spectrum, the market is very integrated. In other words, the institutions are competing with one another, and the same types of students are attending these institutions. The market is relatively well informed. I would never say it's a highly informed market, but students do know quite a bit about schools, and schools know a lot about students. It's mainly privately financed, and by that I mean that for the sources of revenue associated with undergraduate education, most of those sources are coming from the students themselves or from their families. So it's largely privately financed at the top. The top or the most selective schools are populated by students who tend to be quite elastic to institutions' academic and other resources. In other words, they're sensitive to whether you have a high faculty-student ratio or a low one, how nice the campus is, what classes are like, things like that. And finally, you will see that it is characterized by very strong assortative matching between the educational resources at an institution and the student's college readiness. At the other end of the spectrum, at the very non-selective end, almost the opposite conditions prevail. And in the middle, it's in the middle. Okay, so we'll get to look at all of this, and I'm going to try and show you evidence on each one of these pieces. Let me just quickly review the market, especially because I know not everyone here is an American, and even if you are, you don't necessarily study higher education. There are about 7,500 post-secondary institutions in the United States. About 1,000 of those are selective. Okay, so we have many that are non-selective. We have three types of governance: public, nonprofit, and for-profit. Our institutions are very autonomous compared to most post-secondary institutions in the world. They get to choose who they admit, what their tuition is, what their curriculum is, who they're going to hire in terms of faculty, their salaries, how to give out financial aid, how to raise money. That depends on whether you're a nonprofit or a for-profit, but in any case, they get to choose all those things. Now, I know some of you are associated with public or state colleges and universities, and you know that your schools are considerably less autonomous. But by international standards, even public universities in the United States are very, very autonomous. It is true that you may negotiate with your state legislature over how to set tuition or how to set in-state, out-of-state enrollment, but at least you're negotiating, and you're not having it set by the federal government. The U.S. Department of Education is not making those decisions for you. Selective schools in the United States tend to admit students on a holistic basis. They don't just take account of one thing, like a test score, and have sharp cutoffs. Nevertheless, test scores are statistically by far the most powerful indicator of how selective a school is and of a student's college readiness. So from now on, I'm just going to say that a school is more selective if it has higher median test scores. It is just the statistical predictor that matters. Okay. Net tuition in the United States is what you actually pay if you're a student. That is not equal to the list price or list tuition, and the difference there is financial aid, as we all know. But list tuition is also not equal to the educational resources that a student experiences, and that can differ because of state appropriations in public universities, or in nonprofit universities, it's usually gifts to the endowment or current use gifts that separate those two things. So it's important to realize those are not all the same thing. What you pay for tuition is not the educational resources you experience. And as Jim Paterba pointed out in the introduction, the most selective schools, which have very high resources per student, are strikingly often free for low-income students. So it tells you that net prices and educational resources can really be very, very different from one another. We do have federal intervention in the U.S., but it is mainly in the form of portable grants. In other words, you can take them to any college or university, subsidized loans and tax credits and tax deductions. So I'm not going to be talking a lot about the federal government today. I like to think of the U.S. post-secondary market as a market in which there are many price distortions or price interventions, but it's still not centrally controlled. Okay, so that's how I'd like you to think about it today. Just reviewing some of my previous work, which we need to load up so that we can understand some of the other things that I'm talking about. In about 1875, we had I would describe the U.S. higher education as autarkic. Most people just went to the most local institution or one of two local institutions or something like that. After that, it became significantly more geographically integrated. And this was particularly true for students with high college readiness. You'll see in a moment that it's still not terribly integrated for students with low college readiness. And also a lot of this integration took place immediately after World War II, between about 1950 and 1970, when testing became standardized, financial aid became standardized, and people started to realize, oh, I'm really ready for college, or I'm really not ready for college, and colleges were able to start to find the students who suited them. As the market became more integrated, the students with high degrees of college readiness tended more and more to attend the institutions that had the most resources per student, and I will show you that. It's quite a dramatic change. Many of the students with high college readiness could pay, but many of them also could not pay for the educational resources that they would have experienced at those schools, and that is really the beginning of serious financial aid, as these schools reach out to low-income, high-achieving students and find ways to make school affordable. This was achieved by having increasingly large subsidies at selective institutions, and their students are by far the most subsidized students. I may come back to that point again because I think it confuses people a lot, but a lot of the most selective institutions subsidize their educational resources the most for students, although at least at private universities, the private nonprofits, the students pay it back later in life when they ask them for their alumni donations. Okay, so it's not free. But the consequence was that the correlation between parental income and educational resources fell over this long period of time. So let me just show you some data on the things that I said. This is the percentage of students who apply to a post-secondary institution that's at least 250 miles distant from their home, and I'm going from 1950 to 2010. The top set of dots is for the students who are the highest aptitude students, at the 90th percentile or above on college assessments. Then I have median aptitude students and marginally prepared students. And what you can see is that the students who had a very high degree of college readiness switched from being largely in autarky, they were just attending their local institution, to nearly all of them are applying to at least one institution that is at least 250 miles distant. So they're in a geographically integrated market these days. If I do something more sophisticated and I estimate a statistical model of college choice, so this would be something like a conditional logit model, okay? So a pretty big model of post-secondary choice where I can take into account all of the characteristics of the students and the characteristics of the colleges and then the match between those things. What do I see? Well, I see that distance is decreasing in importance for college choice, that the match between my own college readiness as a student and the college readiness of the peers I would experience at a school is increasing in importance, and that my parents' ability to pay for the school's educational resources is decreasing in importance. So that would be true if I do these pretty sophisticated statistical models of college choice, but all of these changes are much more dramatic for students with high college readiness, and they are not at all dramatic for students who are marginally prepared for college. Okay, the next thing I want to show you is how much the sorting of students and educational resources changed over time. The earliest year I can show you is 1967 for reasons of data. So let's have a look at that. On the horizontal axis is an institution's per student instructional resources. And what I've done is I've given each school the number of seats it had in 1967 and then just ranked them. Okay, so at the far right hand of the horizontal axis are the schools that have the highest per student instructional resources. And if the top school had 1,000 seats, that's how many ranked places it's allocated. And on the vertical axis, I've done something very similar, except what I've ranked is students in terms of their college readiness. And again, I've just taken students in order and ranked them from the top scoring students to the bottom scoring students. Okay? And so if the top scoring student went to the school that had the highest instructional resources per pupil, and then we went down like that, rank, 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 what we would see was just the 45-degree line, right? And we do not see the 45-degree line. In fact, what we see is that students' college readiness and instructional resources don't seem very closely related, although there's a little indication here, okay, on the right-hand side, that there is some positive relationship as you get towards the schools that have the highest instructional resources. Let me show you the same chart with the same schools in it for 2013. You can see that there is a lot more assortative matching. Essentially, the students with high college readiness are going to the schools that have high instructional resources. Okay, there's an enormous increase in the matching between students' college readiness and schools' instructional resources. Although you will notice that if you look at the bottom left-hand corner of this chart, as you get into the schools that have lower instructional resources and the students with lower college readiness, it starts to look again a bit like a cloud. Okay, there's not really much of a relationship there. And in fact, what I will tell you about, so let me just, I'm sorry, here we go. This is the most selectives, where most of you spend most of your time. The very selectives, the selectives, and these are kind of the non-selectives here, just to give you a sense of where they are on this chart. In fact, this non-selective group, and the two charts that I showed you, 1967 and 2013, I showed you a panel of schools so that I was kind of holding the schools constant and I wasn't really expanding the schools that I was looking at, and that was to be fair in terms of the comparison over time. But in fact, this group down here has really expanded enormously over time. Okay, this is where most of the enrollment expansion in the US has occurred. And let's have a look at that quickly, just so that we can put some things in perspective. This is the growth of enrollment of the non-selective sector since 1967. And the way I've divided selective and non-selective here is to say that you're a selective school only if you ask students to submit test scores, grades, and letters. They're at least recommend them when you submit your application. Okay, that's one way of thinking of what a selective school is. And you can see that now the non-selectives by that criterion totally dominate enrollment in the United States. Okay, another way of deciding where the dividing line is between selective and non-selective is to look at schools that call themselves open enrollment schools. These are schools that really don't even require you to apply. You just sort of walk in the door, and as long as you can pay, you're enrolled. And again, you'll see this enormous expansion in the open enrollment. It's not quite as dramatic, but you can still see that's the part of the U.S. post-secondary market that is expanding fastest, is the non-selective part. And I want you to keep that in mind throughout everything else that we're going to be talking about today. Okay, so that was just a bit of history to get us up to today. And now I want to make the points that I described earlier in my introduction, in the motivation. The highly and non-selective parts of the market differ in all of these ways that I described earlier. Now, I've already shown you evidence on two of them, so I'm not going to show you again that there's a big increase in the degree of assortative matching and that student sensitivity to institutions' resources has increased over time. I mentioned that already with these longitudinal studies, but I am going to try to make the rest of the points for you here quickly. Okay, so what does the U.S. post-secondary market look like today? Well, what this is showing you is the enormous difference in instructional resources per pupil between the most selective schools on the one hand and the least selective schools on the other. And it's really very dramatic. So what we have at the top end of the selectivity distribution is schools that have instructional spending just under $100,000 per pupil, and core spending of around $150,000 per pupil. Core spending adds to instructional spending student support, academic support, and institutional support. Okay, so it doesn't really matter which of the two measures you use. They both, as you can see, they go up together very smoothly. At the low end of the selectivity distribution, we have schools where instructional spending and core spending are under $10,000 a year, $5,000 a year, $4,000 a year is quite common. Mind you that this is not tuition. This is what they're actually spending to educate a student, okay? I'm going to show you a slightly different version of this chart in one moment. I want to emphasize that on the horizontal axis here, because you're going to see a lot of charts that have the same horizontal axis, what I have here is the institution's median SAT combined score. That's the math plus the verbal score. And institutions are binned in 20-point categories. And it's the institutions that are shown here, not the students. So just to be clear, if you happen to be a student and you're attending a school that has a median SAT score that's below yours, you're in with your institution. Okay, so it's the institutions that are being shown, not individual students. The SAT does not give out score points in a way that is even in terms of percentiles. The SAT is designed so that it is more sensitive over the range in which students are very college ready. And as a result, if I were to show the same chart and just use national percentiles, so this is exactly the same chart, but I've now changed the horizontal axis to national percentiles instead of the SAT score, okay, you will see that things look much more compressed. And that's telling you that a lot of the action among the most selective institutions is up just in the top few percentiles of the test score distribution. I'm going to continue to show you charts with the SAT score on the horizontal axis, and I'm doing that because the selective institutions are interesting, and so I want you to be able to see the interesting action and not have it all crowded up on the right-hand side of each one of the figures. Okay, so that was instructional resources and core student resources. Per student, we saw that it was dramatically different among institutions. I'm now going to look at some measures of competition and integration and show you that they are also dramatically different among institutions. So I have 4 different measures of competition and integration. The first one is just the average number of applications filed by an institution's students. And you can see that the least selective institutions, most students are just applying to that school. Just one application is filed. Whereas at the most competitive, most selective schools, what we see is students on average submitting 10 applications. So very big difference there. Another measure would just be the share of an institution's students who applied only to that school. So they really never considered another school very seriously. So it's not clear that school A just needs to compete with school B. And you will see that, again, among the non-selective institutions or the very least selective ones, most of the students are only applying to that school, whereas that behavior is extremely uncommon for the most selective institutions. Another measure of competition or integration might be whether school A has to compete with schools outside of its own little commuting zone. Is it only competing with other local institutions? Well, this just shows you the share of competing applications. In other words, applications submitted by my students to other schools that are to institutions in another commuting zone. And again, you can see that this goes up very steeply as we go from the least selective to the most selective institutions. If instead of looking at a commuting zone, which is a pretty small area, I look instead at applications submitted to an institution in another state, you can see that that also goes up very steeply as we go from the least to the most selective institutions. So by all measures of what we would think of as integration or competition with other institutions, the least selective don't look like they have much competition. They're just maybe competing with a few local institutions, and the most selective look like they're in a very integrated national market where they have to compete for students with all the other institutions potentially. All right, that was competition and integration. Now let me show you a little bit about information. Probably the best measure of whether we have very much information about a school is whether the institution provides information to something called a common data set. The common data set is one data set that is gathered by a consortium to be used for all of the college guides in the United States. So it's used for Barron's guides and the Peterson's guides, and it's used by U.S. News and World Report and so on. And it's so that schools can provide comparable information to all of these different organizations, and so that they don't have to provide it time and time again. You'll notice that the least selective institutions, none of them are really participating in the common data set. And in fact, it's quite difficult to find information about them. Go and try on the web. And what you will find is they'll say lots of wonderful positive things about themselves. But then when you try to get down to the nitty-gritty, well, tell me about how much you spend on this, what's your faculty-student ratio, how many of your faculty have graduate degrees, what are your students' graduation rates in different programs, you won't find that kind of information. On the other hand, the most selective schools in the United States, 100% of them are participating in the common data set. Okay, so we can find out lots of information about them, and it's all in the college guides with which we are familiar. I also note that here you could really begin to see the sort of break between the selective and the non-selective schools. There's this very steep increase in the participation in the common data set in a range between about 900 combined on the SAT and about 1,100 combined on the SAT. And keep that range in mind, because it'll show up on some other figures as well, as being sort of the dividing line between the non-selectives and the selectives. And finally, I want to show you the share of undergraduate revenue that is paid by students, because I think students have an incentive to internalize the effects of their education on their own human capital, on their later earnings, on their later life outcomes when they are paying for their undergraduate education. And they may have less of an incentive to do that when someone else, a third party, is paying for their undergraduate education. So what do I mean when I say it is paid by students? Well, perhaps it's easiest to think of what is not paid by students. If I am getting a government grant, I am not paying for that directly. I'm never going to have to repay that. If I have a loan and I'm going to default on it, or I'm just not going to pay it back under one of the income-based repayment schemes, that counts as not being paid. So I'm counting those as students who are not paying either. Okay? Or if my tuition is being subsidized by state appropriations, I'm not going to pay that back. Okay, so as you can see, if we look at this chart, again, what we can see is that at the least selective end, only about 40% of undergraduate-related revenue is really coming from students themselves, whereas at the top end, it's close to 100%. Now, this top end is actually a kind of a funny thing, because as many of you know who in this room who teach at nonprofit universities that are very, very selective, those students tend to be subsidized by income from the endowment and other donations. But for the purposes of thinking through the incentives here, I think we're going to count that as money that is paid by students, partly because they themselves do actually make the donations later in life, but also because the institution has a strong incentive to internalize the effects of its own education on its students' later outcomes, because those later outcomes are what determine that inflow of later donations or revenue. So from the sort of economic incentives point of view, we're going to count it as money that ends up getting paid by students. Finally, I'll just note before I leave this topic that the share of undergraduate revenue paid by students does not differ a lot among the most selective institutions. They all have a lot of their undergraduate revenue paid by students. But once you go down to the non-selectives, it's all over the place. So what I'm showing you here is the 10th, 50th, and 90th percentile of the share of undergraduate revenue paid by students. And if you know very much about the non-selective part of the market for education in the United States, you will recognize that this is the incredible diversity of our non-selectives. On the one hand, we have non-selective institutions that are extremely demanding. They're often for-profit institutions. They give out certificates and other credentials that are very valuable to employers. We have a bunch of these in Silicon Valley, and they charge a lot of money, and they expect students to pay for that. Most of the students who go to those schools pay for their own degrees. On the other hand, we have also for-profits, still sticking with the for-profit theme for a moment. Also, we have for-profits where almost 100% of their revenue is coming from federal grants and the grants that are given to military veterans in the United States. And they would be down at the 10th percentile, where almost none of the students are paying for their own undergraduate education. And they're both types of for-profits. Actually, the public institutions tend to sit someplace in the closer to the median there. But my point is that the the non-selective part of the market for higher education in the United States is incredibly diverse. It is not like the most selective end, where you could say the schools are not quite interchangeable, but they're close to being interchangeable. At the non-selective end, they are far from being interchangeable, and that is a theme that we will see again. Okay, so far, I've just kind of reviewed where the market for higher education is. Now let me show you what I think of as being the new and, to me, surprising and maybe even very surprising result. So what I have been working on now for about a year is measuring the productivity of post-secondary institutions. So what do I mean by productivity? I mean the productivity of $1 of educational resources. So the numerator is going to be the causal increase in lifetime earnings that is triggered by enrolling in the institution. This I'm going to call value added. Okay, I realize that post-secondary institutions don't just increase earnings, but we're going to put that aside for right now. We're only going to think about value added in terms of lifetime earnings. In the denominator will be the causal increase in lifetime educational spending that is triggered by enrolling in the institution, and I'll call that social investment. And notice that both of these are longitudinal concepts, not just the first one, the lifetime increase in earnings, but also if I go to a specific college and then that triggers me to not only go to that college, but also maybe to go to graduate school or go and get a professional certificate or something like that, that will be included also in social investment. Okay, so it's not just what I happen to pay out of pocket at the beginning, it is all the educational resources that get devoted to me longitudinally is going to be in the denominator. So it's very important that we have longitudinal data for both. The main problem for measuring the productivity of post-secondary institutions is the bias that arises through vertical and horizontal selection. Vertical selection is the problem that different schools enroll students who differ in terms of their college readiness. So it is not reasonable to compare, a Tulane University to which is very selective, to a local community college and say that the difference in the students' earnings just has to do with the difference in value added between Tulane and that community college. That's just not true. They're admitting students who have very different levels of college readiness, so they probably would have earned something quite different anyway. And dealing with that is the primary problem in trying to measure productivity. There also is a horizontal problem which is non-trivial, and that is that if you were to compare Tulane, which is located in Louisiana, to an equally selective school that is located in a labor market that has much higher earnings, you might end up making a sort of false apples to oranges comparison again, and that's because even if the schools enroll students who are equal in college readiness, they still could differ in other ways in terms of their labor markets and other ways that might affect their earnings. So I'm going to try to deal with both of those problems. I'm not going to go into the nitty-gritty of the method here today, although please feel free to read the papers, and also feel free to ask me about them, because as you know, I like to talk about the nitty-gritty. Okay, so what's the method from 1,000 feet? Well, I tried to think through experiments. I really wanted to put the method in terms of experiments that people could understand and that made sense, and I'll also explain to you later why it is that I like this method rather than just trying to control for students' test scores or something like that. Okay, so the method deals with vertical selection by finding each school's on the bubble range in admission. On the bubble means that the students are just maybe going to be admitted, maybe not. It's the range where the school is almost flipping coins between whether the student gets admitted and does not get admitted. And I'm going to treat the students who are in the bubble range as randomized by the admission staff, and the result is that I get thousands and thousands and thousands, tens of thousands, hundreds of thousands, I'm not sure, but many, many thousands, of A versus B experiments where college B is just a little less selective than college A. Okay, so I was on the bubble at college A, I didn't get admitted, I go to college B, and it's only a little less selective. That's kind of what you get from those experiments. And I'm going to deal with horizontal selection by finding students who are choosing among colleges that are in an indifferent set. In other words, they're very, very similar on selectivity grounds. They may look extremely similar, and it looks like the student is the one who's just flipping a coin at the end of the day. And I'm going to treat those students as randomizing among the schools in his or her indifferent set. And that's going to give me lots of A versus C experiments where colleges A and C have very, very similar students. And those are usually schools that are geographically approximate to one another or that look very similar on numerous other criteria. And then I take paired comparison methods and I combine the results of all of these pairwise experiments to obtain value added in social investment that is as free of selection bias as possible. Now, paired comparison methods are probably most familiar to all of you because through sports, because they are used to rank tennis players, they are used to rank chess players, they are used to give us the rankings, they're used to do rankings of college football teams, all kinds of things like that. So this turns out to be exactly the same sort of statistical problem, although it's actually easier to use it to derive value added than it is to rank football teams. And the reason is we don't have to worry about home field advantage, things like that. Okay. All right, so just to summarize the method, I'm going to gather all the differences in earnings and social investment from all of the vertical experiments involving students who are on the bubble at some selective school and exposed to randomization by the admission staff. Notice that I really need the longitudinal data here to get the social investment differences as well as the earnings differences. I'm going to gather all the differences in earnings and social investment for all the horizontal experiments, like two colleges that look very similar to one another, involving students who choose between equally selective schools, and I'm going to combine all the experimental results using paired comparison techniques. So there are literally hundreds of, I should say I'm using population data, I'm using administrative data, this is not sample data. Okay, so I'm looking at every student's application portfolio, so there are hundreds of thousands of these experiments. So what are the strengths and limitations of this method? The first strength, of course, is the purpose I went in with. I'm trying to remove selection bias, and I think a lot of the selection bias is removed by this method. The second strength is the one that I have become convinced is the most important one, and that is that common support is always fulfilled. I am never comparing two schools without thinking about a student who would actually be choosing between those two schools potentially. Okay, there is none of these experiments is saying what would happen to John Smith if he went to MIT when John Smith could never get into MIT or would never consider MIT. MIT had to be in his application portfolio, okay? And furthermore, he always had to have been a very plausible MIT student, okay? So that kind of common support, I have become convinced, is really why it is that this method, I think, works better than just controlling for something like test scores. In addition, there's no functional form at all imposed on the relationship between value added and college readiness. This, again, is an advantage vis-a-vis sort of simple linear controls or something like that. And it's pretty obvious which assumptions need robustness tests. It's basically how I find the bubble range is really the main thing that needs robustness checking. There is a big limitation to this method, which is not just this method, but almost any method that would attempt to do this. There is probably no general fix for the selection problem of I go to a non-selective institution versus I don't go to a post-secondary school at all. Everyone in this room is aware of the literature on what is the return to enrolling in college, and that's about these marginal students who are just on that margin. But most of the fixes that we know for that problem are very specific to a certain set of institutions. They may be local to a certain set of conditions. They may be an historical artifact. It's a natural experiment. It's a policy experiment. None of them are general fixes that I could use broadly. So what I'm going to do is I'm going to show you productivity relative to the least selective institutions, and I will not attempt to tell you how productive the least selective institutions are relative to their near alternatives, which are things like a student perhaps going into the military or doing on-the-job training or engaging in some kind of credentialing program that is not considered a post-secondary program in the US. Okay. All right, so now let me build up the productivity numbers. I'm going to start by just showing you wage and salary earnings through age 32. So this is not value added. This is just raw wage and salary earnings. And this is for the cohort who graduated from high school in 2001. So they're about age 32 in the last year earnings data in which I observed them. And I've discounted everything back to age 18 using a 2.5% real discount rate, and I can show you various other discount rates in the paper. But what you can see is what you would expect. Students who go to institutions that have higher math and verbal SAT scores, in other words, they're more selective, have higher wage and salary earnings. And that part of that may be the institution's value added, but of course part of that is the fact that they also just had higher college readiness before they were admitted to school. And you'll see that the difference is quite large. It's about $500,000 in difference between the least selective and the most selective institutions. And just to give you a sense again of where they are, the most selective in the top bubble, very selective, selective, and sort of non-selective, depending on how you cut it, is between about 700 and 950, something like that. Okay. All right, so now let's do it through age 65. Obviously, I can't observe the high school graduating cohort of 2001 through age 65. So what I did was I observed them up through age 32, and then from age 33 onwards, I projected their earnings in a few different ways using earnings data, administrative earnings data from the Treasury. And this is my preferred projection, but again, if you look at the papers, you can see a variety of other ways. It's not going to matter very much, except for the very top group. The very top group is quite affected by which type of projection method I use. Now, you might say this looks just like the other chart, but notice that the vertical scale is now quite different. The top of the vertical scale is no longer 800,000, but 8 million. Okay? And again, this is discounted back to age 18 using a 2.5% real discount rate. So through age 65, lots and lots of earnings. Again, this is still just earnings. This is not a value added. Let's look at the same chart and put value added in there. So now the value added numbers are coming out of that method that I described earlier, where I'm trying to take account of vertical and horizontal selection. And you can see that value added is also increasing pretty much monotonically with an institution selectivity, but it's not increasing at as nearly as fast a rate as raw earnings. And this is particularly obvious if we look out on the right-hand side, where the institutions are very selective. A lot of the earnings of those students is due to the fact that they were just very college ready in the first place, and they would have always had pretty high earnings. Okay, so that you can see value added does go up, but it does not go up nearly as fast. Also notice that this is a normalization, okay? I do not know the value added of the least selective institution, so I have just normalized it to be 0, and therefore this normalization is not completely innocuous, which is something I could discuss, but you should keep in mind that the value added is just normalized to 0 for the lowest value added institutions. It's not truly 0, okay? I don't know that it's 0. It could be negative. It could be negative. Because it could be that it's worse to go to a low selectivity institution than to go into the military or to do on-the-job training or something like that. It's not necessarily a positive number. All right, so that's value added and lifetime earnings. Now, that's the numerator. Let's look at the denominator now. This is lifetime social investment in post-secondary education. And remember that this is longitudinal. So if you keep going to school longer and longer, you're going to have more and more of this social investment. And that's exactly what we see. Social investment is quite low for students who are going to the least selective schools. That's because not only are they going to schools that don't spend very much on them in the first place, but they don't tend to stay very long in those schools, whereas it's very high, around $600,000, even when discounted back to age 18 using the same discount rate, for the students who attend the most selective institution. And again, that's because they're going to schools that spend more money on their education, and they stay longer in school consequently. So what we have is a race between the numerator and the denominator, right? We know that the numerator value added is rising as we go to more and more selective schools, but also the denominator is rising as we go to more and more selective schools. So which of the two is going to win? And this next chart shows you. When I first saw this chart, this totally shocked me. I have to say, in fact, it changed the whole nature of my interest in this topic, because I had not expected it to look like this at all, and it sort of changed what I thought I ought to be thinking about. I won't tell you what I expected it to look like. That's probably not a good way to set you up, but it's just, this is what it looks like, and this was not what I had expected, because what does this say? This is, my characterization of this is that it's kind of flat and a little lower at the non-selectives. Then it's rising in this area where we're sort of on the border between the non-selectives and the selectives, and then it's pretty flat again. Okay, so what does this say? This says that $1 of educational resources is generating about the same value added for the only mildly selective institutions and the most selective institutions. And yet, as you saw in previous figures, these institutions differ enormously in terms of educational resources, right? Just enormously in terms of educational resources per student. So it's not at all obvious that $1 at Harvard or Stanford or University of Chicago should produce the same amount of value added as the $1 at a school that's only very marginally selective, just a little bit above non-selective, okay? So that's the first thing to take away from this. That is a very striking result, very, very striking result. And then the non-selectives are less productive, and again, don't take too seriously the fact that they're below the zero axis. That's really the normalization. We just know that they're less selective than, less productive with $1 than the selective institutions. Okay, so so that was the average. This is showing you some dispersion, and what you'll notice is that there isn't that much dispersion in productivity among the very selective institutions. All of the dispersion starts to grow as we get into the middle of the selectivity band, and then it just explodes as we get into the non-selectives. And that shouldn't surprise you, because you may recall earlier that I showed you that the non-selectives were a very diverse group. But what this is showing you is that their productivity is also very, very diverse. We can talk through the exact magnitudes. When I first saw this, I thought, oh, this can't be right. And then I actually looked at lots of examples. I thought, oh, no, this can be right. So but they're very, very diverse group in terms of their productivity. Whereas you can see at the most selective schools, I know we all make a big deal out of which one you go to, but it's not a big difference. Okay, so let's assess where we are. The productivity for $1 of social investment tends to be flat across a wide range of selectivity. As I said, this is striking because these schools have very different educational resources, and it suggests that somehow the resources are scaling up with college readiness in such a way that there are no easy gains to be made by taking $1 from one selective school and sending it to another selective school. There's some gains to be made by doing that, but it's not as though if I took dollars from Harvard and allocated them to Ohio State or something like that, it doesn't look like much would happen, okay? Right? All right, and it doesn't mean that all the selective schools make maximally productive use of their resources. It could be that they're just similarly inefficient, which is kind of what I think, based on being a professor. Also, where we are, relative to the least selective institutions, the productivity of $1 is really sufficiently positive at the selective institutions that the fact that they have additional resources seems like a good investment. I mean, if you looked at the numbers on the vertical axis, it looks like for every $1 that is being spent at those institutions, it is generating multiple dollars of value added. Okay, so that makes it look like they're all good investments, unless we've really normalized things incorrectly. And I don't think we could have done that as incorrectly as it would need to be. We also have concluded that less selective institutions are less productive on average, but their productivity is also much more dispersed, so that students can make quite big mistakes by choosing a a low productivity one instead of a high productivity one. They're often next to one another in the same commuting zone. It's not obvious what the differences between them are. This is potentially problematic because the non-selectives, as we saw earlier, are expanding much faster than the selectives, and they are less productive on average, and also it's just easier to make mistakes. Okay? And it's hard to say, as I've emphasized, whether the non-selective institutions are a good investment vis-a-vis other alternatives. So we've already seen quite a bit of evidence that predictors of strong market forces prevail among selective schools, but not among the non-selectives. We could also test further this idea that there may be a connection between productivity and market forces by looking at similarly selective schools and seeing whether the same sorts of predictors are correlated with productivity. I'm just going to be clear that what I'm about to do is not causal, it's just correlational, it's suggestive, but I think it is suggestive about the relationship between market forces and productivity. So I just ran a regression where the dependent variable was an institution's productivity, which I measured, and I dummied out the school's median test score in these 20-point bins. So selectivity is now out, okay? And I put in as the covariates of interest some of those measures I showed you before of integration and competition, my information measure, and the share of student-related revenue paid by students. All three of these types of measures, the more competitive, the more integrated the school is, the more informed people are about it, and the larger the share of its student revenue that's paid by students. Those all are positively correlated with productivity. I should emphasize, again, this is a correlation. It's only suggestive evidence, but it does suggest there may be a connection between. Finally, let me get, in my last minutes, to the economic implications of all of this. Because I think we want to take a big step back and say, okay, now we've learned some interesting things about the US market for higher education, but what are the big lessons and why does this matter to the economy more broadly? Well, I'm going to take a little, it'll seem like a short digression and say that because we need to understand what economic model could explain all of the phenomenon that we've seen so far. I'm not going to claim that this is the only economic model, but it seems to me like it is the most concise one. And if correct, it has important implications. And it's the model that I think is probably right myself. So here's the simple model I'm going to propose. There's going to be single crossing in the productivity of educational resources and college readiness. So just to remind you, what is single crossing in this context? It basically means here on this will be very familiar to a lot of you. College readiness is my CR. R is my educational resources. P is just going to be the undistorted price of an institution, before tuition subsidies and things like that. And what single crossing says is that this function, which I've defined here as M, is monotonic in college readiness. And that just means a student who has higher college readiness is always willing to pay more per unit of educational resources than a student with lower college readiness. Okay, that's kind of a familiar condition to us in many other settings, but we often don't think of it with regard to colleges and universities. Let's just go back to my simple model. So I have single crossing. Students are going to maximize their return on educational investments. Students are insensitive to arbitrary features like geography so that all the institutions are well integrated into the market, and students are fully informed and not liquidity constrained. So this is a kind of obviously a kind of ideal setting. Okay, so if that is the model of what happens, what would we see? We would see that student choices and market forces will generate an assortatively matched allocation in which students who have higher college readiness are paired with more educational resources. And here's the crucial thing. Each dollar of resources will generate the same value added, and institutions will be pressured to be X-efficient or productively efficient. And you may recognize that this is the same type of market equilibrium that we get in a lot of other settings. For instance, this is really the same as a Tibu equilibrium in local public goods. We get the same types of results. We get stratification. That means we get some schools which have students with higher college readiness than others, and there's a sort of stratified equilibrium. We get positive assortative matching between college readiness and educational resources. We get allocative efficiency. The return to a dollar is pretty equal across institutions. And we get productive efficiency that's forcing the institutions to be more productive with a dollar of educational resources. And we get a kind of standard condition there that you get in all of these types of models. Okay, so now how does this model help me understand the data? Well, I would apply it to the selective schools, where its assumptions don't fit, but they don't outrageously not fit either. Okay, so I think it helps us to understand why we see the equilibrium that we see for the selective schools, where we see this stratification, we see the assortative matching, and it looks like we see pressure to have productivity that is very similar across a range of schools, productivity of $1. And we just say it doesn't really apply to the non-selective schools where none of the assumptions seem to fit. We have weak integration, we have weak competition, we have poor information, a low degree of self-pay, and we have students who just aren't willing to look outside, their zip code or a couple of zip codes. All right, so if that is the model, by the way, I should say, I found, as I said, I found these results somewhat surprising, but once I ingested them, I said, this model really does explain part of what it is that we are seeing, and it made me think that students who I never think of as flexible, rational, informed, interchangeable investors may actually be better investors than I had thought. Okay. So what are the implications of a model like this? The first implication is that to make its maximum contribution to growth, a higher education sector in an economy needs to allow educational resources to scale up with college readiness. Now, that may seem obvious because that's what we happen to do in the US, but actually in most countries in the world, educational resources are kept very similar across students who have high degrees of college readiness and low degrees of college readiness. And it is not popular necessarily with people to suggest that there should be these vast differences in educational resources per student. And no other country has this spectrum with incredibly high educational resources at one end and quite modest educational resources at the other end. That is unique to the US. That top tail of the distribution does not exist in other countries. And so the extent of scaling up is quite unique to the US, and it may mean that we have educational resources contributing more to economic growth in this country than in other countries, precisely because we allow that top tail to exist, okay? Where educational resources, huge educational resources are paired with students who have very high degrees of college readiness. Elsewhere, Philippe Aguillon and I have argued that top US research universities are unusually productive. They tend to be standouts in research, but it may be that just we have a whole tail of universities that are able to be productive with very high educational resources and contribute a very disproportionate amount to economic growth. All of this would be exacerbated if you have a model like the model of Osamoglu, Aguillon, and Zilibati, which says that in a highly developed country, economic growth is unusually propelled or disproportionately propelled by innovation, and that higher education contributes disproportionately to innovation, as opposed to, say, imitation of technology, right? We often think of education doing a variety of different things, but highly advanced education might contribute very disproportionately to innovation. Okay, so that would suggest that we should really be paying attention to whether our post-secondary sector is organized in a way that's efficient for economic growth. While all of post-secondary investments may actually be earning high returns relative to alternatives, and I don't dismiss that possibility because my normalization doesn't tell me anything about that, reallocating students and resources from the least productive schools to the more productive schools is sort of an obviously pro-growth thing. If you go think back to that productivity chart where we saw how dispersed productivity was for the non-selective institutions, just moving students from the least productive non-selective institutions to the more productive non-selective institutions might be a good thing, okay? It seems kind of like it would be very pro-growth. And policies that facilitate market forces in higher education, such as better information, better competition, financing that makes students and schools internalize the consequences of their choice, may also be pro-growth because it may promote productivity in this very important sector that potentially contributes to the economy through innovation and through a lot of other ways. So that's all about economic growth. And at the end of the day, I do come down on this idea that there is something special about the US market for higher education, that it may be incredibly vital to American economic growth, that we should not take it for granted that we have this unusual setting, that we should not take it for granted that we have these institutions that are incredibly highly resourced and that are fortunate enough to not only have the high aptitude people from the US, but have high aptitude people from around the world engaging with those educational resources, that may be a very special part of our economy. However, that same model also has implications for income equality, and this is where I'm going to stop because I think it's important too, okay? If there is strong single crossing between college readiness and educational resources in tertiary education, what is good for growth, in other words, that enormous assortative matching, may be very bad for income equality, right? It sort of says you come into college with high college readiness, you're already going to have pretty high earnings, even if I don't give you very many educational resources, but guess what? I'm going to pair you with huge amounts of educational resources as opposed to very modest. Well, even if all schools are equally productive with the dollar, some schools have a lot more dollars, okay? And some students experience a lot more dollars. And that is not great for income equality. So that sounds, it sounds like we're doomed, but perhaps not. It's worth remembering that college readiness is partly due to primary and secondary education. It's not just innate aptitude. It's, you know, all those kids who go to elite high schools in the United States, they don't all start out that elite at birth. There probably is something to the schools they go to. And there's lots of reason to think that educational resources may be more productive in early childhood programs that serve the disadvantaged than the advantaged. Okay, so it is not the case that single crossing necessarily has to work the same way for early childhood education, say. It doesn't. It could go the other way. But I think what it tells us is that if we want to grow fast, we should feel extra pressure to make all of our students have high college readiness so that we don't have these big gaps in college readiness as they go into tertiary education, where I think this strong single crossing applies. And with that, I'm going to stop, and I would be delighted to take questions.